Hello students, in this video we are going to talk about exponential equations, so equations that contain exponents. The principle is actually very simple. If we have equations in index form with the same base, so in this case here we have the same base a, if a power x is equal to a power y, then if the bases are the same, we can derive a conclusion that x must be equal to y. That kind of like intuitive, I think. So formally, then there is a requirement that a should be greater than 0 and a is not equal to 1. But we will not worry about that at this point, at this level. We are just going to talk about base a and the base have to be the same. Okay, so let's look at some examples. Let's say here we have 5 power x equals 25. We are going to express both of them, both sides, as exponents with the same base. So I am going to try and express 25 as index form with base 5. So obviously 25 is 5 squared. So now because we have the same base, 5, and the exponents are x and 2. So since the base are already the same, we can make a conclusion, derive a conclusion that x must be 2. So 5 power x equals 5 power 2. Conclusion, x must be 2. Okay, all right, so let's look at the next example. So again, we are going to try and express both sides of the equation as index form with the same base. So I see that the left-hand side is on base 2. So we will try and express 16 as index form with base 2. So we know that 16 is 2 power 4. So now again, both sides have the same base already, so we can derive a conclusion that the exponents must be the same. So x plus 1 must be equal to 4, which in this case, just as solving normal linear equation, we subtract 1 both sides, so we have x equals 3. Okay, so next example. We have the left-hand side index form with base 3. So we will try and express 1 over 27 as also index form with base 3. We know that 27 is 3 power 3, but then it is in the denominator. So then to express it as base 3, we can write it as 3 power negative 3. So power negative, remember? Yeah. So since now the base on both sides are already equal, then we can derive a conclusion that the exponents must be equal. So x minus 1 must be equal to negative 3. So solving an equation in this case for x, we add 1 both sides, so x must be equal to negative 3 plus 1 is negative 2. Okay, so we have some more example. So in this case, on the left hand side we see base 4, on the right hand side we see base 8. We can't really express 8 as 4 power something. So then we will have to choose a different base for both sides of the equation. When we look at 4 and 8, both of them can be expressed as exponent with base 2. So I will write 4 as 2 power 2. And then we see that there is still power x minus 2. And we are going to express 8 as 2 power 3. And then obviously 8 power x on the right hand side. So both of them now can be expressed as exponent form with base 2. So when we look at the exponents or the indices, 2 power 2 and then power x minus 2 again, with power rule, we will then multiply these two exponent and x minus 2. So don't forget multiplying by 2 everything, right? 2 times x minus 2, I will write it this way. So 2 times x minus 2, later on both of them inside the bracket have to be multiplied by 2. And then the other one is just 3 times x. So now because the bases on the left and right hand side are already equal, then we can derive a conclusion that the exponents must be equal. So 2 multiplied by x minus 2 must be equal to 3x. So expanding the bracket, this is what we have. And then subtracting 2x both sides. Remember, if both sides have unknown, we are going to remove one of them. So on the left hand side I have negative 4, and on the right hand side 3x minus 2x is x. So x equals to negative 4. Okay, so let's see, write one more time. Negative 4 equals x, or x equals negative 4. All right. We have one more example here. So again, when we see a quarter and we see 8, so 4, 8, we can express them as base 2. So here on the left hand side, 4 can be expressed as 2 power 2, and then power 1 minus x, and 8 can be expressed as power 3. So inside this bracket, according to negative power rule, we can write it as 2 power negative 2, right? And then again power 1 minus x. So if we multiply out the exponent, negative 2 times 1 minus x, so be careful here, we will patiently write it down so that we are not confused with the subtraction and negative. So most important part right now is that the bases on both sides are already equal, base 2. So now we can derive a conclusion that the exponents must be equal, right? Negative 2 times 1 minus x in the bracket is equal to 3. So expanding the bracket, we have minus 2 plus 2x equals 3. And then adding to both sides will give us 2x equal to 5, and then dividing to both sides, we have x equals 5 over 2, or 2.5. So this is the final answer of this equation. All right, hopefully this is understandable and you can practice with the exercises. Good luck!